Okay, so today we're going to go over the lesson Scientific Methods. Most of this you guys should have come to me knowing. You should know the scientific method and the steps to it. But just in case, we're going to get everyone on the same page and go over it quickly. So basically, if you didn't know, the scientific method is just a series of steps that scientists use to solve their problem. Or a question that is asked. Sometimes it is a scientist that's getting paid by the government. Sometimes it's a scientist being paid by a private company. Like maybe somebody wants a certain type of lipstick or a certain type of shampoo or conditioner or something, and they pay scientists to improve their product or create new products. The scientific method isn't just used in traditional science. Sometimes it's used in agriculture, sometimes it's used in cosmetics, it's used in many places. Okay, so the steps to the scientific method, sometimes you'll see 5, sometimes you'll see 6, but basically when you see 6, there is another step here that's actually really important to me. But you first have your observation, you ask a question, and then you need to do research right here before you form a hypothesis. Otherwise, you may be forming a hypothesis that someone else has already done, and you would be wasting your time. So we're going to go over all 5 of these steps in this lesson. So step 1, asking a question. So again, like I have said, maybe a cosmetic company wants to create a new product or improve a product that people are complaining about. Maybe it's just there's agriculture saying we like this sweet type of corn. Can we isolate the gene so that we can make all the sweet corn, or all of our corn will be sweet? It depends on, what the situation is, will depend on your question, but these are a few examples. And then step 2, hypothesis. Okay, so we all know that a hypothesis is just an explanation of that problem or question, and it really should be based off of research. But it's a prediction, and we haven't proven or disproven it yet. We're going to have to make sure that it's testable. That's a big deal. You don't come up with a hypothesis that you can't test. Otherwise, you're done. You stop there. In science, we make sure that we can test it. We make sure we can get data off of it so that we can, show the world what we've done and share our results. The next step is designing a controlled experiment. The key word is controlled. You're going to hear me all year talk about variables, the independent, dependent, and controlled variables. Those are super important. We've already spoken about them once, and we're going to talk about it basically all year, every lab that we do. The variables are, there should only be one variable that we change, okay? And then there's going to be a variable that we'll measure, and then there's going to be all the other variables that stay the same. And that's really critical that you only change one variable at a time. Otherwise, you don't know what is causing the results. Okay. Designing the controlled experiment. So this is what I've already said. Make sure you only change one variable at a time. Otherwise, if you are that scientist, think of science. I want you guys to start thinking of science outside of the classroom. So far, up until now, you've been given this little piece of paper that says, here are the steps for your experiment. I already know what the answer is going to be. Let's see if you can get the same. But in real life, the scientists don't know what the answers are, or else they wouldn't be getting paid by the company or the government or wherever, or the university, to do this research. Why would the company pay for something they already knew? You're going to provide them with results. And if you don't know what's causing the change, or if you don't know what's causing the improvement or creating the new product, then you can't deliver that to the company or government or whoever's paying you. Therefore, you may not get paid. It's very important that you have a controlled experiment so that you know what is causing any change or creation of whatever your outcome should be. The next thing you need to know about designing experiments is sometimes you're going to be dealing with people. Obviously not us. We are not going to be experimenting on each other, but we will be doing control groups with plants this year. So a control group is a group of things you're experimenting on. In real science, it could be people. volunteering to try your medicine. It could be animals that you are experimenting on, which we'll talk about ethics later in the year. And or it could be, like in our case, a plant group. And we may be adding fertilizer to the plant, or maybe we want to see the effect of sunshine on the plant. Whatever we're trying to see the effect of, we need a control group. And that's a group that just stays under normal conditions. That way we know that this is what a normal plant would look like in normal conditions. And then the experimental group is the group that we're either depriving of sunshine or maybe giving a lot of sunshine or whatever we're experimenting on. So the control group is just normal conditions. Experimental group, they're getting the, different variable. For example, in order to test the effectiveness of a new vaccine, 50 volunteers are selected and divided into two groups. One group will be the control group and the other will be the experimental group. Both groups are given a pill to take that was identical in size, shape, color, and texture. So this was like the experimental design. So the control group, so theoretically nothing, like is as if we did nothing to them, but no one knows who the experimental group is until the end of the experiment. So the experimental group will receive that pill with the medication in it. Then there are constant variables. So the pill stayed the same, the texture of the pill, the color, the shape, the size. So they knew that they were taking the pill, but no one knew if they had actual medicine in it or not. And that way we can, it just gives us more reputation for our results. So a changed variable. So this is something that we change. So this will be the independent variable whenever you do this in the lab. I talk about the independent variable a lot. This is what we changed. So what we changed was whether or not the pill contains the medicine, the vaccine. So those two are usually the ones you guys get mixed up. Just know independent is what we change. The dependent is what we measure. It's dependent on what we change. So if that helps you remember it in a test or a quiz, the dependent depends on what we did in the independent variable. In the example, what is the independent variable? So what did we change? Okay, so what is the independent variable? It's that we added medicine. It's whether or not we had medicine given to the volunteers. So step 4 in the scientific method is recording results. Guys, this is going to be super important for you to keep organized in the class. To keep organized in the class. This is actually very important. And there are people who can get their license taken away for lying about their data. We'll talk about this in class, but the whole issue with vaccines, people not accepting vaccines in America and in parts of Europe, are caused by one scientist who actually faked his data, and he got his doctor license taken away, his physician license taken away, and he had to pay a fine. And now a lot of people, and especially children, because it's the parents choosing for the children, are actually dying because they're not getting the vaccines that they need. So it can be like catastrophic if you as a scientist fake your data, and in the United States they put you in jail for that. Unfortunately, the guy that lied about the vaccines causing autism and various illnesses, he lied about his data, and then he didn't have to go to jail because he wasn't in the United States. He was actually in Europe. So you also have to think about where in the world was this research written, and I don't know, there's things you have to consider when you're reading scientific articles, and we're going to go over that as well. So moving on to step 5, the last one, drawing conclusions. So we are going to be practicing this a lot in the lab. Is you're going to, you can collect data all day, but if you don't know what to do with it, if you don't know how to analyze it, if you can't look at a graph and tell what's going on, we need to practice that. So you're going to prove or disprove your hypothesis. And if you did not prove your hypothesis correct, that doesn't mean you failed. That just means there's one step closer to answering your question. So then you just go back and repeat it, like it says in that second sentence. Just repeat the the scientific method, the steps, not all of them, obviously, you still have your same question or problem. But if you, for example, if Pantene asks you to come up with a conditioner that makes hair less frizzy in this humid weather, maybe you tried adding a chemical to it and it turns out that chemical dissolves hair. That's not good. So then you have to go back and change your hypothesis. Your problem stays the same, right? You still need conditioner that doesn't cause frizz or that helps hair not be frizzy. But you may have to change that hypothesis and experiment a couple of times until you get the results the company wants and is paying for. So in real life, experiments are repeated over and over and over and over again, sometimes across a whole lifetime. Um, it's not always in little 40-minute chunks in middle school. So we'll be, reiterating that all year. And then forming a theory. So a theory is formed after the hypothesis is tested many times and is supported by that evidence. A theory isn't just, something someone comes up with, even though that word kind of makes it sound like I can just, say whatever pops in my head. Like, I think the sunset is orange because of a certain gas that's in the air at the time. You can't just, that's not an actual theory, a scientific theory. So that was your first lecture. And you'll have more of these, and these will be kind of like your homework. Because it's not too difficult to fill out your notes. And then when we go to class, we will practice some of these concepts.